Welcome back. Today we're going to be talking about percent of change. So first we need to know what percent of change is. The percent of change tells you how much an amount has increased or decreased in relation to the original amount. So now let's go ahead and take a look at how we're going to do that. Now we have a very easy way to complete percent of change problems, and that's by using a formula. The formula for percent of change is the new amount minus the old amount divided by the old amount, or new minus old divided by old. So now let's put that into practice with example A. So here we are at example A, and these are going to be looking at percent of change through word problems. So Byron's salary in 2013 was $50,000. In 2014, his salary was $52,500. Find the percent of change. So his boss came in and gave him a raise, and we need to determine if this was a large raise or a little raise. It's always good information to have. So remember, we're going to use our formula, new minus old divided by old. So our new amount in this case is $52,500, because that's how much he's getting paid in 2014, which is after 2013, so that makes it the new year. His old amount is $50,000, so we're going to go ahead and take our $50,000 and put that in the top and the bottom for our old amount. Then we're going to do some subtraction first. 52,500 minus 50,000 is going to give us 2,500, and 50,000 doesn't have anything to do, so we're going to just drag that over. So now we have 2,500 divided by 50,000. When we do that, we're going to get a decimal. So our decimal is 0.05, but this isn't called decimal of change. It's called percent of change. So we need to move our decimal to the right 2 places so that we get 5%. The percentage, so there we know that he got a 5% raise. The next question says Anna is a waitress. The table spends $20 and leaves a total of $23.60. What percent tip is this? So Anna wants to find out whether the table tipped her well or not, and that's good information to have if you are a waiter or waitress. So the new amount is going to be $23.60 because that's the amount after the bill. The old amount is going to be $20, so we're going to put that in our old amount on the top and the bottom. We're going to do some subtraction. $23.60 minus $20 is going to give us $3.60 divided by 20. And then we're going to do some division. 3.6 divided by 20 is going to give it this decimal 0.18, but again, it's not decimal of change, it's percent of change, so we'll move our decimal 2 places to the right, and we're going to get 18%, so she was left an 18% tip. Now let's take a look at example B. Here we are at example B, and this time we're going to be looking at percent of change on a table. So the question asks, what is the percent of change from February to March? So the first thing that we need to do is isolate February and March here, and then we need to determine which one is the new and which one is the old, because as always, we're going to be using our percent of change formula, new minus old divided by old. So the new amount in this particular case is going to be March, because March comes after February in the calendar. So our new is going to be $70 and 34 is our old dollars. Now we could do our subtraction, division, turn it into a decimal, move our decimal 2 places to the right and get a percent. Or we can use our friend, the Desmos calculator. So if we bring our Desmos calculator in here, you can see that we've done new minus old and put that in as an equation. Then we've hit the blue return arrow at the bottom and we've typed N equals. N standing for our new, in this case is going to be 70. And then our old, as we talked about, is going to be standing for 34. Now what you can see here is at the top, the formula ran the subtraction and division for us and gave us the decimal 1.0588. So we're going to now need to do some rounding. So we're going to round to our second decimal point, which is going to be 5. We're going to find our place, look next door, 5 or greater, add one more. So it looks like that 5 is going to become a 6. So if I do that, I've got 1.06. 1.06 is going to be our decimal. But I don't want a decimal of change. I want a percent of change. So I'm going to have to move my decimal 2 places to the right. 1, 2. And when I do that, my percent is going to be 106%. Now I know what you're thinking to yourself, whoa, Mr. Porter, you can't have more than 100%. That makes no sense at all. The truth is that you can have more than 100% because what it's saying is it's increasing 100%. So it's increasing the $34 that it was. So it's increasing all of it, another $34, plus some extra. And in that case, if we add 34 and 34, we get 68, and we're actually going up to 70. So we know that the price is basically doubling plus in order to go in March instead of February. The next question asks, from June to July, the cost of the train ticket increased 20%, and it wants us to fill in the table. So we need to figure out what 20% of our money is there. So we've got $115, and we know that's going to be equal to 100% of the cost of the ticket. Now we know that it's going to be increasing 20%, but we don't know what a 20% increase is, so that's going to be our x. So now we can do some cross multiplication. 100 times x is 100x. Then we need to do 115 times 20, and we can do that in our calculator. 115 times 20 is going to give us 2,300. Now we've got a one-step equation. We know how to solve those. So we're going to draw a wall down from our equal sign, divide both sides by 100 because the opposite of multiplication is division. These are going to cancel. 2,300 divided by 100 is going to give us 23. Now, that's a 20% increase there of $23, but that's not the cost of the ticket. That's just the 20% increase. So we need to take the original amount, which is $115, plus the $23 for the increased ticket. So 3 plus 5 is 8, 1 plus 2 is 3, and carry down our 1. So the new ticket price is $138. So make sure that you answer what the question is asking us. It's not asking for how much just the increase is, it's asking for what the new price is inside the table. So you always want to make sure that you answer your question. And notice that I put a $sign there because it's a word problem, so we have a word answer. Now let's take a look at the next one. So here we are at example C, and it says, what is the percent of change from Wednesday to Thursday, round to the nearest percent? So it's given us an additional direction. We need to round to the nearest percent. And we have to figure out what Wednesday and Thursday is because it doesn't give us the numbers. We're going to need to read the graph. So our Wednesday amount, we can see at the very top of our graph here, is going to be 900. And our Thursday amount, all the way down here towards the bottom of our graph, is going to be 100. So the key is now we need to figure out which one is our new and which one is our old. Thursday comes after Wednesday, so Thursday is going to be our new amount. Wednesday is going to be our old amount. So now that we know these two numbers, let's go ahead and pull in our Desmos calculator again because that method seemed a little easier. So the first thing we're going to have to do is we're going to type in our formula. So this time we're going to type in our formula. We've got new, and we're going to type that as new minus old, and we want to divide that by old. Now that we've got our formula set up, we need to put in for our n. So our n, in this case, is going to equal 100. So type in our 100. Then we go to the next line to type in our old. So in this case, we have our old is equal to 900. So we type that in. And we can see that, again, our calculator is going to do the calculation for us. So it's given us a negative 0.888888888, and at the end there, it's rounding to a 9. That's just because the calculator runs out of space to display this endless number. It doesn't actually mean that there's a 9 there. So we need to focus on our negative 0.88. It says round to the nearest percent, so we're going to round this 8 here to a 9. So we're going to end up with negative 89%. So let's go ahead and take a look at that. So we're going to take our amount here. We've got negative 0.89. We're going to move our decimal place 2 places to the right, 1, 2. And when we do that, we end up with negative 89%. And you can have negative percents of change. It just means the amount went down or decreased. Now let's take a look at the last example. Here we are at example D, and it says, since 2010, each year the population of Lake Forest neighborhood has decreased by 25%. So we can see it's gone down 25% from the previous year. Show this on the graph provided. So we need to fill in information on our graph. So the first thing we need to do is figure out a decrease in 25% for each of the years. So the first number we have is 8,000, and we know that's going to be a decrease of 25%. We can solve this one of two ways. We can do our 8,000 times 0.25 for 25%. Let's clean that up a bit. Doesn't look super great. Times 0.25 and get an answer that way. Or we can use our good friend, the proportion, and say that I know that 8,000 is 100%. and I don't know what the 25% decrease would be. 25%, the percents are on the bottom. I don't know the amount, that's the number on top. It doesn't matter which way you do it. You can solve the proportion or you can multiply by the decimal. Either way is correct. Whichever way you are most comfortable with should be the one that you do. Don't choose the method that is not easiest for you. Now we have 8,000 times 0.25. I'm going to do the decimal. When I do that, I get 2,000. So I know there's a 2,000 person decrease. That doesn't mean that it's 2,000 people now. It means I have to subtract the 2,000 from the 8,000 we already had. And when I do that, I get 6,000 people. So for 2011, I need to fill in the graph that goes up to 6,000. For the next year, I have to figure out how many people were there. So we're starting with 6,000 people this time. And again, I can make my proportion if I want. I could say 6,000 over 100 for the 100% that we're talking about, and we don't know what the 25% decrease in that is. Or we can multiply by our decimal point, whichever one's easiest for you. I'm going to do the multiplication by decimal again, so 6,000 times 0.25 is going to give me 1,500. So again, that's not 1,500. That means I need to do subtraction. 6,000 minus 1,500 is going to give me 4,500 people. So again, I'm going to fill in my graph for the next year, about halfway on the 4,000, all the way up. So then the last year of my graph, I need to make sure that I have my 4,500. Again, I can multiply that by 0.25. Or I can put that on my proportion. So I could say 4,500 divided by 100 is equal to, I'm not sure, over 25%. Whichever way works for you. This time I'm going to multiply by the decimal again. When I do that, I get 1,125, but again, that's not 1,125 people. I need to do some subtraction for 4,500 minus 1,125. When I do that, I should get 2,875. So again, I've got to put that on my graph, so that's going to be very near to the 3,000, and then I'm going to shade that region in. When I've done that, I have my entire graph filled in based on the questions that it gave me, and that brings me to the end of this question, brings me to the end of this set of notes, and brings us to the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.